Hello, kids. Yes, it's me. I'm back again. And look, I'm down in the corner. I managed to get my PowerPoint fixed up. So now you can see my pretty face while I do these presentations. And what is today's topic? Well, we are still on botany, guys. We're still in the study of plants and some really cool plants this time. It's going to be all about the awesome ways that plants survive. There are some really neat strategies out there that plants have used to try and survive in this crazy world of ours. And I'm going to go over some of them in this presentation. First, though, I want to go across about what the main things that a plant like this one, looks familiar, I think it's one of our classrooms, what they need is, of course, sunlight. This one, I think you guys knew this one. They need sunlight, and they use that in a process called photosynthesis in order to make basic sugars in their body. And the chlorophylls that are used to make photosynthesis are green. We'll get to that later on, too, though. But we also need DOIT. Yes, down there you need soil and preferably some nutrients in that soil. You do need air. They need carbon dioxide and oxygen to grow, and so they need the air. And as of course you down there in the corner, you need water. These are the four basic things. But I'm going to show you some ways some plants kind of get around if they don't have all four of these. Let's look at sun first. When plants grow leaves, it's kind of cool. They grow them in this kind of triangular shape you can see here. Sometimes they're bushy like this one if there's plenty of sunlight. But in a lot of places, they're going to be triangular like the ones on the left. And the reason for this is this means the leaves on the bottom can still get some sunlight. They're not covered by the leaves on top of them. So many trees have this triangular shape. Which helps all their leaves collect as much sunlight. It's no good having leaves in the middle, like in the middle of your tree, where the other leaves above it take all the sunlight from it. So it's all about exposure. And when you have a lot of sun and you have all these things that work out very nicely, you get things like this. This is a rainforest in the Caribbean where there was lots of sunlight, lots of soil, lots of water, everything they needed. And look at that. The plants can go crazy if they're allowed to. You'll see about 6 or 7 different kinds of plants in this one. And one, of course, jungle teacher ninja. All right. So like I said, when things are good, this is what your general leaves look like. They're big, they're wide, they're flat, they collect sunlight. But that's not always the way it is. There's some places where it's very dry and they need to try and conserve the moisture, or it gets too cold and that can damage the leaves very easily. So you get things like this. We call them needles on a lot of coniferous plants. But what these are actually are modified leaves. These are leaves that have curled up and they become very hard spikes like this. And the main purpose for this is preservation of moisture. A lot of these will show up in dry places or very cold places. The other advantage is that they can freeze. There's a reason trees lose their leaves in the fall, because the leaves freeze solid in the winter, they're destroyed. So these ones can actually, which is why we call them evergreens. Many of them are evergreens because they don't lose their needles. The needles are actually modified leaves they don't have to lose. There's one more extreme past this, where we go from leaves to needles to basically spines, you might call these, or thorns. This is a cactus. And those thorns you see on it, yes, those are also modified leaves. Very, very modified to the point of now being used more for protection. And you can see around them, the actual skin of the plant is green. That's where most of the photosynthesis is going on. Now they're protected by these thorns while they photosynthesize from the actual skin. So different approaches to getting sun and how you're going to work your leaves so they're either used for photosynthesis or for protection. What's next? Oh yes. What if there's very little sun? Well, you have these which create food. They generate it by parasitizing soil and other plants around them, and also makes them not plants. What you see are mushrooms and fungi. They are not plants. One of the defining features of plants is the use of chlorophyll for photosynthesis from the sun. So I kind of include these so you can see that the mushrooms and toadstools and fungi, they're not plants. They may look like it, but one of the key features is they're not green. They don't use the sun to make their food. Hold on, drink. Thank you. So now we do have water, and everyone would love that. The plants love that. However, what if that water just started to disappear? Okay, we're going to have plenty of sun in this situation, but now we're only going to have no water. Okay. There's very few places in the world where you have no water. Let's just say you have just a little bit of water, just a little bit. This is all about acquiring as much as you can and conserving it. And of course, we go back to the root of the problem, a cactus. What cactus will do is they'll often have roots that spread out really wide. And when they spread out really wide, they can collect as much water as fast as they can when it finally rains. Or, uh-oh, did I block this? No, can you just see the root there? Yeah, can you just see the root at the very edge there? I thought I was going to block it with my little, well, with my pretty little face down the corner there. You can just see the root at the bottom of the dandelion. Can you see what that root's doing? It's going deep. It's going deep, not wide. It's going down. So when it finally does rain, where the sand or the soil will collect all that water, the cactus will collect oodles of it very, very, very fast. All those roots just suck it with it, and it pulls it into the cactus. It starts to swell up with water, which is what it has to do in order to survive. The dandelion doesn't quite get it as quickly. But when that water dries up like this, now the cactus is left with nothing, which is okay. It's stored up as much as it could with all those roots just taking as much as they can. But look at the dandelion. Look at the bottom of the dandelion. That's still in a little bit of water. The water is not completely drained away. So it goes very, 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 very deep. And if you ever pull a dandelion out of a yard with the root attached, you will see that. It's usually one very straight root, and it goes very, very deep. So we can tap into water that's very deep in the ground, even during dry times. So two methods that roots use to try and get as much water as they can. This is a cool plant. This is called the Jericho plant or the resurrection plant. It's got many different names, but what it does is this is one that's sitting in water, having a great time growing. But when that water dries up, and they often live near deserts where it dries up quite a bit, watch what it does. It will curl up into a ball like this that basically looks dead. And if you touched it, it's dry, it's brittle, you would think it's dead. But in this next video, watch what happens when someone puts it in water. So she puts a little sand in there, digs a little hole in there. That's what the plant's going to go into. Gives it some water, not a lot of water, it's just some water, and plops this in. Now, it does look dead. It can sit like this for months and years. But when it finally gets water, look. This is, of course, sped up. This occurs between 2 to 4 days, depending on the size, the species, and the amount of water that's available to it. And it just stretches out. It's like, oh, I've been waiting so long for this. Thank you. And it's always ready to grow. I had one of these when I was a kid. Being a child, I forgot about it. And I did find it months later, sitting in the shelf in the closet of my room. And I went, neat. I pulled it out. I put it in water. Boom. It did this. It started growing. So it's really kind of cool. You see these in the stores, you should get one and give it a shot. It's really kind of fun. And look on the inside also, it can activate its chlorophyll. It can start to photosynthesize. And it will grow like this until it runs out of water, and it curls up, and it just waits for the next rainfall. Some plants have almost no roots at all. In the Caribbean, we call these air plants. They might have other names in different places. What they do is they have almost no roots that go in the ground. They just collect the moisture from the air around them. They're very interesting plants. They grow very slowly. They don't need a lot of nutrients around them. They get a lot from the sun, and they'll attach themselves to trees like this. And when it rains, they will collect the water as it runs down the trunk, or sometimes they'll just absorb it right from the air. They are not parasitizing the plant. They are not soaking up nutrients from the plant. They're perfectly fine. They just live on the side of it. So they're very interesting roots that don't go into the dirt. They just kind of cling on to where they are and make do with what they've got. This is called, in Canada, it's called duckweed. Duckweed is a plant that gets lots of sun. It's a very simple plant, very tiny. But look at the roots, or should I say the root. They have like one little thing sticking down. It doesn't go in the soil, it stays in the water. And when things are right, they can grow. Now, what you see here is not one duckweed plant. These are millions of them. And here you'll see millions of them. And if there's too many nutrients in the water, it's almost too good of growing conditions, because of course they have all the water they want. They have the sun they want. And if there's nutrients flowing in the water, there's too many of them due to pollution, this can happen. And you might go, oh, look at that. It's a beautiful carpet. Well, actually, it's not that good, because what this is doing is blocking the sunlight from reaching all the other plants and the animals that are underneath it. So this is a sign of too many nutrients in the water and probably pollution from somewhere nearby, and can actually really limit the amount of wildlife that can live in this water. But plants can do that. So what if we have a situation, this is called a fen or a bog, where the water in the soil is what's called very acidic. It's there, you can see there's water, but it's not very nutrient rich. As you can see, there's plenty of water there. There always will be. There's plenty of sun, but you don't see a lot of trees. You don't. I mean, there are trees, but they're not huge. There are little patches of them, and that's usually where there's soil mixed in with it, not the peat and the moss that you'll see around. Here's another shot of one. And only certain plants can live in areas like this where there's very few nutrients in the soil, and they've got a really cool adaptation because we got the sun we need, we got the water we need, we got the air we need, we got the soil, but there's not much in the soil for nutrients, so they get their nutrients in a very kind of cool way. We'll start with a plant like this. Now, this is not the plant that does it, but do you see those little things, the little droplets on it? That's called dew. Dew can form on plants in the morning when the air condenses. During the night, it condenses on the plants, and then, of course, it'll warm up during the day and disappear. Well, this plant's called the honeydew plant. not honeydew melons, honeydew plant. The dew you see on this is not dew. It's actually little tiny, very, very, very sticky droplets of digestive juices. It's supposed to look nice and shiny, and it probably even tastes good. But when you're an insect and you touch this, the honeydew, watch what happens. Of course, I have videos on this. So there's the droplets on it. This is only sped up a bit, not a lot, but it is sped up a bit. And these things curl around, and all the little droplets touch onto the insect. And slowly, so you can see the people in the background, you can see it's been sped up from the people in the background. And it curls around it and slowly digests it right there on the stem. And as the animal slowly dissolves, the insect, its juices are absorbed by the plant, and that's where it gets its nutrients from. And it's very nutrient rich. It's another animal, not a plant, another animal. And sorry, this is a plant eating an animal. Let me specify that. So that's where they get the nutrients from, and a couple other species too. We have the pitcher plant. Not that pitcher. Not that pitcher, although it's closer. More like these. There you go. They do actually get their name from the pitcher you see on the left. Not the one throwing the ball, the one that holds water. Because you can see they kind of look like little bottles. They do hold water inside of them. And inside the water is sweet smelling to attract insects, and you'll see in the next video, the insects fall in the water. There's little spikes pointing down, and they can't climb back out. They fall in the water, they drown. And of course, it's not just water. It's little digestive water that will slowly dissolve the animals, and it will absorb the nutrients from the liquid inside of it. And it's just really kind of cool. Watch this. It's going to start, is it? There we go. Okay. They're very tall. Look at that, huh? And there's many different kinds, so many different shapes. Some hang from trees, some come from the ground. Here's the fly sitting on the edge. You have to remember there's little spikes on this that point down, and when an insect goes down, it has a hard time to get up. You can even see some. There, you can see them. And it's slippery. Look at it slippering. Look at it slip. And kerplunk. I'm going to try and get out of this. Oh, it's going to get you fly off. It's slippery. I'm not sure. Oh, kerplunk. Even bees. I mean, you can't sting it. It's not going to do anything to it. But see, look. There it is in the water. And it's going to fall back in, and eventually it just drowns and then slowly digests. There's something else in there too. There's two things in there that have fallen. This plant's going to be very well fed. And yeah, once you're in there, you drown, and then they just slowly digest. Don't worry about the exoskeleton. All the juicy stuff inside is dissolved. Here's someone who cut a pitcher plant open, and look at the collection of exoskeletons that are left inside a mature pitcher plant. Isn't that crazy? They can't dissolve the exoskeleton of the arthropods, but they dissolve everything inside of them. And that will collect, and they stay there. They don't come out. Maybe that's why they're so tall. The taller you are, the more stuff you have inside you, so you have to be taller. Those were pitcher plants. Last one is probably the most popular one, and surely one you heard of. Is a Venus flytrap, straight from WKRP Cincinnati. And the Venus flytrap is very well known because it's the one that almost looks like an animal, almost looks like it has jaws. There's another shot of one in the wild. And not surprisingly, like the other two, these things open up, and they smell very good to insects. They actually do attract them with a nectar-like smell. Watch the video here of this fly, and what you're going to notice is these little tiny hairs sticking out. In order for it to close, 2 of these hairs have to be triggered, not 1, because it's a waste of time and energy to close on something and miss it. So they can walk on it relatively okay until they touch 2 pieces. Now this might have been a cold day. It closes slowly, and the fly barely notices. That might be why it didn't close well. But when things go right, like on this one here, it hits 2 and boom, done. No, they can't climb out. Those fingers enclose over the top, and they're done. They're held in. Okay, this one's kind of cool. These guys are trying to. Oh, move over. Okay, I'm coming in. Here it comes. Yeah. Oh, this stuff's delicious. And look, it's licking the nectar. It's having a good time. This is really good stuff. And move over. Move over. Okay. All right. Sorry. No, keep moving over. That's good. And you can see what's going to happen. What a fine mess you got us into this time. And here's a little clip of someone who opened it up. Didn't open it, so they waited until it opened up later on, and that's what's left inside the 2 flies. Again, exoskeleton cannot be dissolved, but the insides are completely liquefied and absorbed by the plant, and that's where they get their nutrients from, as well as the sun. Here you go. So to review, we have the plant has the sun, it has the soil, it has the air, and it has the water. And if they can get all 4 of these, great. But if they can't get all 4, they always find other ways to survive and adapt, because that's what life does. So I hope you enjoyed this presentation, kids. You all take care, and I'll see you for the next video. All right. Bye-bye.